So this is the second lesson on binomial expansions for the Year 2 version. We've already looked at how to expand brackets of the form 1 plus or minus some term here with a power of n. But what we're going to look at next is what we do if this number isn't a 1. Everything we've dealt with so far has had a 1 here. But what do we do if we don't have a 1? Because our expansion, our rule, only deals with 1 plus or minus x to the power of n. We know the rule, we know the expansion is 1 plus nx plus n bracket n minus 1 x squared over 2, and then that carries on n minus 1 n minus 2 x cubed over 3 factorial, and so on. But that rule specifically only works when there's a 1 there. So we've got to work out what to do when there's not a 1. And it's fairly straightforward. And before I actually work through this question, I'm just going to take the 4 plus x to the power of a half, and I'm going to rewrite it in a form that we can work with. And what we're going to do is we are going to take the 4 plus x and we are going to factorise 4 out of it. So these two things here are absolutely the same thing. They're exactly the same. If I multiply the 4 back in, I'll get 4 plus x. So what I can do now is where these brackets are, I can replace the 4 plus x with 4 bracket 1 plus x over 4. So I've got a big bracket, and then I'm going to write this in red so we can see it different. So we've got this. And there's one more step that we can take to get it looking the way we want, and that's to remember a rule from GCSE, which is, well, probably even earlier than that, which is that 2 terms raised to a power is the same as each of those terms being multiplied together raised to that power. So what I can now do is apply the power of a half to the 4 and then the power of a half to this bracket here. So this is going to be the same as 4 to the power of a half times by 1 plus x over 4 to the power of a half. And then, because this is just the square root of 4, which is 2, we're going to be working out 2 lots of that expansion, and that expansion starts with a 1, which means we can deal with it. So that's what the question becomes. So we can write that here. This is the same as 1 plus x over 4 to the power of a half, and we're just going to keep that 2 on the outside until we're ready to bring it back in and pretend that we are working out 1 plus x over 4 to the power of a half. Using the rule, that's going to be 1 plus n x plus n times n minus 1 times x squared over 2 plus n times n minus 1, times n minus 2 x cubed over 3 times 2, can't fit it on, we need to go up to x to the 4, that's quite annoying, but let's do it. A half times minus a half times minus 3 over 2 times minus 5 over 2, So I just keep taking one off. Each time I add an extra bracket, I've got to take one away. Times x over 4 to the power of 4 over 4 factorial, 4 times 3 times 2. That's in a square bracket. All of these terms we're going to times by 2. So let's keep the 2 there still and start simplifying. That's going to be 1 plus x over 8 plus, well, minus actually. There's my rubber. There it is. Minus, so I've dealt with that. We've not got any numbers on the top, so we've just got an x squared over 2 times 2 times 2 times 16. So that's 8 times 16, which is 128. The next term is going to be positive because I've got 2 negative signs. I've got a 3 on the very top and a 3 on the very bottom, so they'll cancel. X cubed on the top over 2 times 2 times 2 times 2, so that's 16 times 4 cubed. 16 times 64 is 1024. Don't forget to cube this. The 4. That's quite a common mistake for people to just times it by 4, not 4 cubed. So just make sure that you're not one of those people that fall into that trap. Keep your eyes out for that kind of thing. The next term, onto this term here now, is going to be negative. That 3 is going to cancel with that 3, and nothing else will cancel. We are going to have a 5 on the very top, so 5x to the power of 4 over 2 times 2 times 2 times 2, 16 times 2 again, 32 times 4, 32 times 4, that's this 4 here, and then times by 4 to the power of 4. That is 32768. Okay, and then the very last thing to do is times everything by 2. So 2 there, that's going to halve all of these numbers. So plus x over 4 minus x squared over 64 plus x cubed over 512 minus 5x to the 4 over 16384. Okay, so notice that within this question as well, I've asked which values of x the expansion is valid for. We said in the previous video that the expansion is valid when the x term is between minus 1 and 1. So whatever's here needs to be between minus 1 and 1. That means that if I had like a 2x there, it would be 2x that needs to be between minus 1 and 1. And you'd need to divide by 2 to say that x needs to stay between minus a half and a half. So if you've got a 2 there, then it becomes more restrictive. We've got an x over 4. The next thing to be aware of is that it's not when this is valid, when there's a number there that's not 1, it's when we've turned it into something to do with 1, it's when this is between minus 1 and 1. So this question is valid, or the expansion, sorry, is valid when x over 4 is between minus 1 and 1, which actually means I need to times up because it's asking me about x, not x over 4. It's going to be valid when x is between minus 4 and 4. Notice that you can write that in modulus notation. that the modulus of x needs to be less than 4. I think we've done the functions chapter 2. Don't worry if you've not. We'll just keep writing it like this for now. If you want to write it like this, fine. If you understand it, that's fine. If you don't like it, just keep writing it like this. You'll always get the marks. So that's the main idea of these types of questions. Change this so that it's a 1, and you will have some sort of adjustment to do at the beginning. So if we have another question to have a go at, we're only going up to x cubed this time. It's not always going to be a 4.5. I'm not sure why I've got 2 questions back to back like that, but you will come across others. So if we apply the same kind of method to the previous question, we're going to take the 4 out and have 1 minus, this time it's going to be 3x squared over 4. And all of that's being raised to the power of a half, which means we can apply the half to the 4 and then to the bracket. 4 to the power of a half is 2. Whatever that would have been, that might have been like, I don't know, 2 to the minus 1, which is also half. It might have been 3 to the minus 2, which is a 9th. So you would not write a 9th here. I have to write a half. I have to write 2. Anyway, so this is well, it's all important, but this is the bit that we're going to concentrate on next. We are going up to the x cubed term. Notice that says x cubed. I might actually change, just going to tweak the question actually. I'm going to change that to a 4. You'll see why in a minute. Okay, so we have got 2 big bracket 1 plus n x, don't forget that minus sign, plus n times n minus 1 times x squared. And I'm going to stop there. Why am I stopping there? I'm stopping there because I am going to be squaring x squared, which will get me an x to the power of 4 term. So the powers of x are going to jump up 2 at a time. So if I did the x cubed, if I did the next term, the 4th term, and had a cubed here, that would actually end up being x to the 6, which I don't want. So I can stop at the 3rd term in this question. So let's simplify. In fact, I'm going to do this a little bit different. I'm going to bring this 2 in now. It's going to make things easier. I don't know why I didn't do it on the last video, on the last example. If I multiply the 2 in now, I can cancel out a half in each of those 2 terms, and I can change that to a 2. That'll make things a bit easier. That cancels that out. So we're going to have 2. We're going to have a minus sign. We are going to have 3x squared over 4. Then we are going to have, will it be a positive or negative? It's going to be negative. The reason it's going to be negative is because I am squaring this negative number, or this negative term here, which is going to make it positive, and then I'm timesing it by minus 1 again. So the next term is going to be negative. Next thing to decide is what's on the top. On the top I'm going to have 3 squared, which is 9. I'm going to have x to the power of 4, which we've already talked about. And on the bottom, oh, I've forgotten something. What have I forgotten? I've forgotten to divide by my 2 factorial. Let's do the bottom. It's going to be 4 squared, which is 16, times 2, which is 32, times 2 again, which is 64. For what values is the expansion valid? It is valid when 3x squared over 4 is less than 1, we need to make that be an x. So I'm going to times by 4 and divide by 3. And I'm going to square root. Notice I don't need to worry about plus or minus because it's a modulus. If it had been plus or minus, it would just switch the plus and them. It would just be plus or minus already anyway, so we don't need to worry about that. So that's going to be the square root of 4 over 3. You can rationalise that if you want. No one's going to expect you to. No one's going to care really. Okay, so that's when this one's valid. I've got some other examples that are a little bit trickier. One is similar to one we did in the last video, where we had to have two terms that we dealt with. This hasn't got any scaffolding this time. On the last example we had like a part A, part B. This is just like throwing you straight in there. So have a little think how you might work through this example, and when you're ready to, you can watch what I do. So what I'm going to do is bring up the denominator as a negative power. This hasn't got any powers attached to it. This could have been squared or cubed, or it could have been root 1 plus x. They could have had a square root, but it's just 1 plus x. So we don't really need to do anything. Well, we don't need to do anything at all with that. This is the thing we need to worry about. So I'm going to put the 1 plus x to the side for now, and I'm going to work out what to do with 3 minus 2x to the minus 2. And what I'm going to do first is make this be a 1. So I'm going to take out a factor of 3. That 3 and the bracket needs to have the power of minus 2. So that's going to be minus, no it's not, it is going to be a 9th bracket 1 minus 2x over 3 to the minus 2. So this is the expansion that we're going to work out, and we need to remember to times it each term by a 9th when we've done the expansion. I've not specified what term to go up to. Let's go up to x cubed. Okay, so first term 1. Next is n times x. Then we've got n times n minus 1 times x squared over 2. And then we've got n minus 1 x cubed over 3 times 2. We're going to keep the 9th sat there for now. I'm not ready to deal with that yet. I'm going to simplify each term. First term is always 1. Next term is going to be positive 4x over 3. The third term is also going to be positive because we're squaring this negative, and then we've got 2 more negatives, so that is going to be positive. What can I cancel? I can cancel a 2 there and there, and I can cancel one of these 3's. This is 3 squared, remember, with a 3 here. So I'm just going to move that extra 3 so it's not in this bracket anymore to down here. That's going to give me 2 squared, which is 4. So 4x squared over 3. The next term is going to be oh, I made another mistake. I need a -4 in there. N times n minus 1 times n minus 2. I was worried about the cancelling. That 3 can cancel with that 3. That 2 can cancel with that 2. This term will be positive as well, because this bracket is going to be negative. That's going to cancel with that negative there, and then I've got 2 more negatives which are also going to cancel. In terms of on the top of the fraction, I've got a 4 and a 2 cubed, that's 8, so 8 4s are 32. And on the bottom, I've got 3 cubed, which is 27. Now we can bring the 9th in. And 32 doesn't have any factors of 3, so I'm just going to need to times 27 by 9, which is 243. Let me just check that. Yeah, 243. Okay, we've not finished because we've not times it by the 1 plus x. We need to times it by this 1 plus x as well. Okay, we're going up to x cubed. When I times the 1 by everything, it's just going to be the same thing again. But then I'm going to add on x times everything. I'm going to line it up so the x terms are the same. So x times a 9th is x over 9. 4x over 27 times x is going to be 4x squared over 27. This is going to this one's going to become 4x cubed over 27. And I don't need the last term because it's going to be x power 4, and I didn't want x power 4. So we just need to add these terms up. This is going to be 7x over 27. You can check that on your calculators if you want to. I think that's right. I might check my calculator. Four over 27, add a 9th is, 7 over 27. 4x squared over 27, add 4x squared over 27 is going to be 8x squared over 27. And I am not going to attempt to add the last term without my calculator. 32 over 243, add 4 over 27 is 68 over 243. Okay, so that's an example of how to do those types of questions. Variations on this type of question that you will see in exercise 4b, they might ask for, say, just the x cubed coefficient. If that's the case, you wouldn't need all of these terms. What you would do if they'd asked for a particular coefficient is you'd look ahead to which terms will give you x cubed terms and just add those two together. So if they just asked for the x cubed coefficient, you would only need to concentrate on these two. You'd still need to do all of this work. But you would need only to then add the two terms up that would give you an x cubed term. If they'd asked for the coefficient, you don't write the x cubed in. That's something else that some people aren't always sure of. If they'd asked specifically for the coefficient, the answer would be 68 over 243. Don't write the x cubed, or you shouldn't anyway. You wouldn't lose marks, but it's not good maths. Okay, so the next big kind of thing you need to be aware of, which we did talk about in year 12 but comes back again in year 13, is the whole why we do this. So the end of this lesson and the next lesson are all about what the point is. Why do we want to expand these brackets? And the first reason is to find approximations. We've already talked about the fact that big terms will be really small if x is really small. So if x was like 0.1, this term would be really tiny and wouldn't really contribute much to 1.1 if x was 0.1 to whatever power we're raising it to. We talked about all of this in lesson 1. What that does mean is that we can actually work out approximations. So they might want us to work out the square root of 1.1. And we can use this expansion because that would be when x is 0.1. And we do the expansion, we'd work out 1 plus x to the power of a half up to however accurate they want us to be. We do that expansion, and then into the right hand side, into the answer side, we'd substitute 0.1 and we'd get a number. The idea of this is that we would reduce the use of the calculator. I know that we can type the square root of 1.1 into the calculator, but that's not always been possible. So let's have a go at a couple of the, or I think I've got one question like that. This one's the first 4 terms of the expansion of 1 minus 2x to the power of a half, and it wants us to state when it's valid. So nothing new yet, so we can just get straight on with this. But there is a part 2 to this. So that's going to be 1. Again, if you want to skip ahead, if you want to pause the video and do it yourself and check that we get the same answer, then you can always do that. Anyway, n is a half in this case, times minus 2x. Then we're going to have a half times minus a half times minus 2x squared over 2. We need 4 terms, so the next one's going to be a half times a half minus 1 times a half minus 2 times minus 2x cubed over 3 times 2. What have we got? For the first term we've got 1. The second term is going to be negative. Those 2's are going to cancel. So that's 1 minus x. The next term is going to be negative as well, because this is going to square and become positive, so I've got an odd number of negatives. What's going to cancel is both of the 2's, that's 2 squared, so I can cancel that with 2 2's. So I'm going to have x squared on the top and just a 2 on the bottom. And over here I'm going to have odd, even, odd, so that's going to be negative. That 3 is going to cancel with that 3. I've got 2 cubed here, so that can cancel with all of these 2's here. So that's going to give me x cubed over 2. So it's valid when 2x is between minus 1 and 1. So when x is between minus a half. Sorry, I shouldn't have put the or equal to. It was just a slip. Equal to, between minus a half and a half. So it's the expansion is valid. What that means is we can use this expansion to approximate values of this expansion as long as x is between minus a half and a half. because that is what will make all these bigger powers be really close to 0 and not contribute much to the approximation. So if we go to the next slide now, it wants us to use the expansion that we've just worked out, which I'll write down again. Just check that's the same. Have I got that right? Minus, 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 half and a half. Yep. Okay. Remember, that does continue forever. So, how am I going to use this approximation, making x equal to 0.01 to find a decimal approximation to 0.2? Well, let's see what happens when I sub in 0.01. I'm going to have 1 minus 0.02, because it's being times by 2, to the power of a half, which is the same as square root. 1 minus 0.02 is 0.98. Okay, how is that going to help us work out root 2? I want you to have a think about that now. Play around with it. See if you can see where this is heading. Again, pause the video. So this is going to turn into a root 2 if I write this as a fraction. I'm going to write it as 98 over 100. Which cancels down to 49 over 50, which is the same as 7 over root 50, which is the same as 7 over 5 root 2. And there's the root. That's what we're after. So I can now link the left hand side to a root 2, which means I can link the right hand side to a root 2, and that is all when x is equal to 0.01. So if I substitute 0.01 into this side, that will give me the answer to 7 over 5 root 2. So it's 1 minus x squared over 2 minus x cubed over 2. So I can now use the calculator to work this number out. So okay, I've typed all that in and I've got an answer. I've got a decimal answer. The next slight problem is the fact that the root is on the bottom. If I let's times top and bottom by root 2. Let's rationalise that denominator. That's going to be 10. So if I times by 10, and then I'm going to divide by 7, that's going to get me my approximation. So times by 10 on the calculator, divide by 7, gives me 1.41421357. Root 2 is 1.41421335. So the 5's right. 62. So it isn't a bad approximation. It's a very, very good approximation. It's right up to here. And in fact, even that one rounds correctly. So that's pretty impressive. Sometimes in the textbook, I've not seen it in an exam, but I've seen in the textbook they ask for the error percentage, the percentage error. And if you needed to find the percentage error, you'd find the difference. You'd divide it by the correct value, so you divide it by the real root 2 and times by 100. So let's do that. So the difference is just the biggest take away the smallest. So this one's actually, this is slightly too big. So the difference is 9.05548 times 10 to the minus 9. This is going to be a tiny error. Divided by the real number, so divided by root 2, times by 100. Is 6.4 times 10 to the minus 7%. So a really, really tiny error. And we only needed 4 terms. So it's a really powerful application to binomial expansions. This is what they used to do when we didn't have calculators, to find out decimal values of roots and all sorts of other things, depending on the power that we had for n, or the value we had for n. Okay, so I've got a couple of actual exam questions, but I'm not going to go through them because I think I've spoken for long enough. What you can now do though is have a look at exercise 4b on page 99. I think there was also a couple of approximation questions from 4a, so if you struggled with the approximation part of any of 4a, you might want to have another go at that now that you've watched this video. Yeah, and I'll see you soon.